we shall now see the procedure to use the Quarters 2 software, which will help you write your Verilog file for a particular digital design and implement it on the CPLD board Krypton. Now this is a very comprehensive document that describes the use of the board along with the necessary software. Now let us see how to actually use it. Now open the Quarters 2 software, click on create a new project. For every design that you make, you should create a new project. Always specify a working directory for the project, and it is advisable to select a new folder for every new project. Say for example, we wish to implement a full adder. So let us create a folder by the name of full adder and select the folder. Give the name of the project also as full adder. As you can see, the moment you type in full adder in the second row, the third row also gets typed with the same name. This means that the name of your top level Verilog module is the same as that of the project name, and it is advisable to keep both of them the same. Now click on next. This step asks you if you have any predefined Verilog files existing which you wish to include as a part of your project. Since we do not have any files at this stage, let us skip this step. This is a very important step. It asks you to select the target device on which you will implement your logic. The CPLD on board Krypton belongs to the Max 5 family, so select Max 5. To filter out this long list of devices into a shorter list, you can filter by using the package named TQFP. The pin count, select it as 144 and the speed grade as 5. So as you see, we have only 6 devices. The correct device to be selected is the second last one named 5M1270ZT144C5. Once that is done, click on next. This step asks you to include any third-party simulator software that you may wish to use to simulate your design. Since we will not be simulating, we can skip this step and click on next. The final page shows you the details of your project, such as the name of the project, the name of the top level entity or the module, the device selected, and so on. If you are convinced, click on finish. If you wish to change something, you can go back. So we click finish. Now comes the time where we will write our Verilog program. So go to open a new file. So select Verilog HDL file and create and click OK. So this opens up a new text window where we will be writing our Verilog program. As you can see, we have now completed writing our code for the full adder. Notice that the module name, which is given full adder, is the same as that in the project. So first, save your code, preferably in the same folder of your project. The next step is the compilation. So click on this play button which says start compilation. Here we shall see if there are any errors in our code. So compilation has now started. So it says full compilation was successful with 12 warnings. Warnings at this stage may be ignored. Now the next thing is called place and route. We need in this step to map all our IO pins to particular pins on the CPLD. Notice that in our code we have 2 outputs and 3 inputs. The Krypton board has 8 switches and 8 LEDs on it. So the 3 inputs can be mapped to 3 switches and the 2 outputs can be mapped to 2 LEDs. So open the window named Pin Planner. As you can see, you have here a top view of the device and just below the 5 lines, 3 inputs and 2 outputs. So now one may ask, how do we know where to give the pin locations? So for this we go back to the user manual, which is present on the ePrayog website. And look at table number 2. So the 8 switches and 8 LEDs correspond to distinct pin numbers on the CPLD. Let us consider the first 3 switches for the input and the first 2 LEDs for the output. So 48, 45 and 44 for the switches. And for the LEDs, we take 58 and 57. So these are all filled in the location column of this window. Now go back to the main quarters window and recompile. This will help the new pin settings to take effect. So now we are done. The very final step is to create the programming file. So here you can go to the tools menu and create and click on programmer. So you can see a program output file by the name fulladder.pof has been created. Now go to file and say, click on create jam, JBC, SVF or IST file. Now, as you know, every file has its own format. The format to be selected for these kind of operations would be the serial vector format or the SVF. So select SVF and save it in a folder, preferably directly in a drive. It will soon be clear why. So we are saving it directly in F drive by the name, say, full adder. And click on OK. The programming file is now ready. So the Krypton board with which you will be working will come packaged in a box as shown here. Now, the box will have the Krypton board along with a USB cable. Now please be very careful while handling the board. Always hold it from the edges and do not touch any of the components on the board with your bare fingers. Now this is the Max 5 CPLD on which we shall be implementing our design. There are 8 switches and 8 LEDs. This is a power switch. This is a USB connector with which this board will be connected to your desktop or laptop computer. There are 4 push buttons also provided. These are general purpose pins which you can use to interface any peripherals of your choice. These can be used as input-output lines in case more number of such lines are required, and where the pre-configured onboard input such as the switches, the LEDs and these push buttons fall short of the requirement. So now let us see how to use this board and to dump our full adder program onto it. So the first step is plug in the USB cable to the USB connector and switch on the power switch. As you can see, there are 3 power LEDs which glow. One here, and one here. Now with the board in on condition, let us dump the SVF file which we have created using Quartus onto this. So now to dump the SVF file which we have created using Quartus, we will use a software named URJTag which is available for download from the ePrayog website as well. So open the URJTag folder, double click on this JTAG executable. So a command window like this opens up. Make sure that the board is in on condition while you use this software. The first command is cable FT2232. Enter. So as you can see, it says connected to the libftd2xx driver. That means it has detected the board connected to the PC. The next step would be to detect the CPLD. The command is detect and hit enter. As you can see, this shows the entire device characteristics, the device ID, the manufacturer and the part number, which is what we expect, the one selected in Quartus 2, that is 5N1270. Now the last and the final step would be to transfer our code, the program file, onto it. The command is svf followed by the path name where we have stored our SVF file. So if you recall, we had stored it on F drive. So it should be svf space f drive slash fulladder.svf and hit and enter. So it gives you a warning and the prompt will disappear for close to 50 seconds, during which the board will be programmed. So as you can see, all the LEDs on the board are now in a kind of floating state, which indicates that the board is being programmed. So now, as you can see, the prompt has come back. Let us test whether our code actually works. If you recall, we had placed the first 3 switches as the 3 inputs and the first 2 LEDs as our outputs. So let's make one of them 1. So we see that the sum bit is 1. So this is for 001. So for 011, we expect the carry to be 1 and the sum 0. So as you see, the carry has become 1 and the sum 0. For 111, both sum and carry should be 1. As you can see that. So with this, you can test out any number of combinations you wish to. Thank you.